Hello, you're on the Atomatech Labs channel, and today we'll be exploring the vast world of Arduino together. This small device, despite its modest appearance, is a powerful tool for creating and bringing electronic projects to life. Let's dive into the main components, understand how the analog and digital pins work, explore power options, and finally implement 3 practical codes. At the end, we will take the first steps in serial communication. So get ready to embark on this electronic journey. Let's start by meeting our hero, Arduino. This prototyping platform is the modern inventor's playground. Equipped with an 80-mega 328P microcontroller at the heart, analog, digital, and power pins, this is our field of experimentation, where ideas come to life. By deepening our exploration, we highlight the importance of components. The microcontroller, our electronic brain, orchestrates everything. The digital pins, D0 to D13, are like nimble fingers that control binary signals, while the analog pins, A0 to A5, can take on variable values. The next step is to make sure our Arduino is powered. This can be done in 3 ways. Through the data cable, through the power cable or power pins. The Arduino Uno has a recommended operating voltage range of 7 to 12 volts. However, it can be powered with a minimum voltage of 6 volts or a maximum of 20 volts. This provides flexibility to use a variety of power sources, such as batteries, wall adapters, or USB connections. It is important to note that when using a power supply of less than 7 volts, some peripherals or sensors may not work correctly, as the Arduino will not have enough power to power all connected components. Therefore, when choosing a power supply for your Arduino Uno, it is recommended to stay within the 7 to 12 volt range to ensure stable and reliable performance. Let's put theory into practice. We enter the first code, a simple blinking LED. We physically connect the LED to a D13 digital pin and load the code into the Arduino. The result is a visual demonstration of code execution in action, showing how to control electronic devices. We move on to something more exciting, controlling the brightness of an LED gradually. We introduce the second code, using a PWM pin to create a smooth transition. We explain the difference between conventional and PWM digital pins, show the physical connection, and run the code, revealing the ability to create dynamic visual effects. We take a leap in complexity with the third code. Now, a potentiometer comes into play, allowing real-time control of the LED's brightness. We introduce analog pins, connect the potentiometer to the Arduino, and load the code. By turning the potentiometer, we demonstrate how physical interaction can influence the Arduino's behavior. Finally, we dive into the world of serial communication. We explain its importance, initialize serial communication in the code, and exemplify the transmission and reception of data through the serial monitor. This opens the door to more advanced interactions and is a crucial step for complex projects. In this example, we will define the beginning of a serial at baud rate 9600, and in the loop function we will check if there is something available at the serial input. Through this interaction with the serial, we will turn off or turn on the LED. We recap our journey, highlighting the main points explored. The Arduino is not just a board, it's a tool that unlocks creativity. With the main concepts and practical codes presented, you are equipped to dive deeper into this electronic universe. Be adventurous, experiment, and remember that every project is a learning opportunity. Thank you for joining us on this journey through the world of Arduino. If the video piqued your curiosity, don't forget to like, share, and subscribe for more electronic content. We look forward to exploring even more together. Until next time, happy experimenting.